Hi all, welcome to the new episode of Tech Insert. Today we will study everything about battery management system. These are all lithium batteries. The one lithium ferrophosphate battery or lithium ion battery that I do not have with me now. This is lithium polymer battery, this is lithium ion, and this is also a lithium polymer battery. You can see it, right? All lithium ion or lithium polymer batteries are basically 3.7 voltage for one cell. When you fully charge a lithium battery, it will reach 4.2 volt maximum. Whatever is the battery type, see this is a 18650 battery, the voltage will be same. Lithium ion batteries are having specific characteristics. We cannot overcharge it, we cannot over discharge it, we cannot short circuit it for a long time, etc. Everything will affect the battery life or sometimes explode it. So we should take specific care to lithium ion batteries. Then how can we charge the battery? Do we give a 4.2 volt DC across the battery terminal? Yes, that can be used for charging, but once the battery voltage reaches the 4.2 volt, we should disconnect the battery from charger, otherwise the battery life will be decreased. Also, when you discharge the battery, we should not over discharge below 3 volt, then also battery life will decrease. If you over discharge the battery to 0 volt and then try to charge it, then sometimes it will not charge. Then we should do a trickle charge, that is giving a 10 volt to the battery terminals for 15 to 30 seconds. Then charge normally, then only it will start charging. When you short circuit the battery for a long time, then also battery life will decrease. Everything should be taken care while using or charging a lithium battery. Manually we cannot do these things. That is why we use a specific kind of circuit for controlling this system. That circuit is what we call as battery management system. In short, BMS. You must charge or use a lithium battery through BMS only. When you compare these two cells, the right side battery is actually a costly one. You can see the difference in height. And it is written as 2600 milliampere. And it really has 2600 milliampere. I have tested it personally. When you check the weight, the right side is having heavy weight. This costly battery is packed with BMS. You can see the notch height. That is actually a BMS system connected on top of this battery. This will increase the height of the battery. You can see the height of the BMS. And also you can compare it with the other battery. There is a notch, but this battery do not have any BMS system. If you over discharge this battery to below 2 volt or 1 volt and measure using a multimeter, then also the multimeter will shows the battery voltage. If you look into this battery, this is actually a lithium polymer battery. You can see a small circuit board connected at the tip of the battery. This is actually a BMS system packed along with this battery. This is a 500 milliampere LiPo battery. This is another lithium ion battery of type 14500. Here also you can see a small BMS connected on top of this battery. These are all 1C battery. That means the discharge capacity is ampere into 1. This is 3.7 volt battery or maximum 4.2 volt battery. If you want 12 volt, what will you do? You have to connect the batteries in serial. So 3 batteries connected in serial to form 12.6 volt maximum. And this is what we call as 3S battery. If 2 batteries are connected in serial, then it is called 2S battery. Actually, the battery pack is what we call as 2S, 3S, 4S and so on. When you connect the batteries in serial, that is 2S, 3S, etc., how will you charge it? In nickel cadmium and all, if 2 batteries are connected in serial, we can give a 2.4 volt across the terminal and it will charge. It is possible. But here it is not possible. We have to make use of balanced charging here. Then the question rises, how will we do a balanced charging? The technique is simple. We will charge each battery separately. This battery we will give 4.2 volts separately and this battery we will give 4.2 volts separately and so on. The BMS system will do all these stuff to you. You don't need to worry about anything. These are the different kinds of battery management systems with different ratings. For charging this battery, that is 18650 or 14500 or in short one cell, you can make use of this BMS. There are 2 types available for that. I will show you both. The peculiarity of this one is we can input the supply for charging using a Type C connector. Using this BMS, we can charge this cell or any one cell we can charge using this one. This is a 1 ampere rated BMS system. That means it can charge using 1 ampere current to battery and discharge maximum 1 ampere current to the load from battery. And if the battery has a less capacity, then maximum what capacity battery has, that will deliver to the load. For charging the battery using this BMS, we can make use of our mobile phone's Type C charger. And this BMS is using micro USB charger. Which one is our convenient one? We can fix that one in our battery charger. Micro USB type or Type C. Micro USB type is a bit cheaper than Type C BMS board. These are two boards and you can see a line on it. You have to break it by bending like this. The breaking is so simple and you don't need to worry about that. I will show you once again. And if you look into this BMS, you can see there are two LEDs, one blue and red. While charging it will be red, and when fully charged this will be blue. These things I will show you. This BMS is using different terminals for charging and connecting the load. This is another kind of BMS system which is 1 ampere rating. This is also used for charging this battery. You can see we can fix this BMS inside this battery itself. See, it is made like that. This is actually a perfect fit for this 18650 battery. This battery do not has a BMS. So we will pull the top part of the battery and can fix this BMS on top of this battery. Just like this. After fixing it, we will connect the terminals to the end point of the battery. Sorry, normally the BMS system we are connecting at the top part of the battery, and the terminals we will be connecting like this. The terminal is so long that we can fix on the negative part of the battery, and the positive part we will bend like this and will spot weld it. And this one is another kind of BMS, and next one is the BMS which is of 2S type. This is 10 ampere rating, and 2S means we can connect two batteries in serial. So the total battery voltage will be 8.4 volt. We will make a battery pack using this BMS, and that time I will explain a bit more about this BMS system. Okay, which one we will take next? This one? No, this one. This is actually a 20 ampere rated BMS which is 3S. 3S means you can connect 3 batteries in series to get a total output of 12.6 volt, that is 4.2 volt into 3. And this BMS has the capability of delivering 20 ampere to the load. Let's see how we can connect the battery terminals into this BMS. As I told earlier, the BMS will take care of the balanced charging to all 3 batteries connected to this BMS. You can see these points as this is 4.2 volt, this is 8.4 volt, and the final one is 12.6 volt. I will break this BMS so that I can separate a single piece of BMS so that we can see everything clearly. Okay, we can have 3 batteries in serial so that we can show the points to you. Okay, let's see. These two are the positive and negative terminals to the load. Charging of the batteries are also done through these terminals. And for balanced charging, we are using 0 volt, 4.2 volt, 8.4 volt and 12.6 volt. This is the 0 volt terminal, and this we will connect to here, that is the negative terminal of the battery. And this is 4.2 volt that we will connect in between here, and 8.4 we will connect here in between, and 12.6 we will connect to the positive terminal of the battery. This is used for balanced charging. The positive and negative terminals to the load is connected here, and also for charging we will be giving 12.6 volt to the positive and negative terminal, so that the balanced charging will happen in each of the batteries separately. There is no LED indicator here. Next we can have a look on 4S BMS. This has the capacity of 30 ampere. For 4S we have to connect 4 batteries in series. That means a total of 16.8 volt, that is 4.2 into 4. These two terminals are the output to the load, that is P positive and P negative. And this B positive connected to battery positive, B negative connected to battery negative, and B1 connected to 3.7 volt, B2 to 8.4 volt, and B3 to 12.6 volt. And finally B plus to 16.8 volt. The next BMS is 3S with a bit high capacity, which is 40 ampere. This one is 20 ampere only. Connections are similar to that in 20 ampere. This is 0 volt, 4.2 volt, 8.4 volt and 12.6 volt. These are the output terminals. Okay, let's make a 7.4 or 8.4 maximum voltage battery pack with 3 ampere capacity. This is the BMS we are using. This is the battery holder. We have connected the battery holders in series, and these are the batteries we are using. The connection diagram to the BMS that I will explain to you. This P positive and P negative, those are the output terminals to the load. If you want to charge, then you can give the voltage to these two pins, and BM, B negative and B positive I will explain to you. These are the two batteries in serial, and B negative we will connect to the negative terminal of the battery, and B positive we will connect to the positive terminal of the battery, you can see, and BM, that is battery middle, that we will connect to this middle terminal of the battery. If you haven't subscribed to our channel yet, please click subscribe button. Press the bell icon so that you will get the notification whenever we upload a new video. If you have connected BMS to the battery pack and not getting any voltage in the output, then don't be panic. Just give the charging voltage for 10 seconds and then disconnect it and then try to measure the voltage. Then it will be fine. Now we will try to charge our battery pack. This is the bench power supply. First we will measure the voltage of the bench power supply. And you can see it is 8.46 voltage. Now we will give the same voltage to the battery pack for the charging purpose. Let's see whether it is charging or not. We can check on my bench power supply. You can see it is drawing 0.1 ampere. You can see, and the voltage is 8.53 voltage. We can test our battery pack by connecting a load. This 12 volt motor I am giving it here as a load. Let's see whether it will work or not. Okay, we are connecting the positive and negative terminal to the motor. Let's watch it rotating. Yeah, it is working fine. So our battery pack is working fine. Now we will test if a short circuit is happening at the output terminal. For that I will use a single strand of wire from the output terminal. You can see that wire, right? You can see the single strand of wire, right? I will focus it for you. Okay, I am short circuiting it. See, nothing is happening. I can hear some spark sound, but nothing more. This is because the BMS is disconnecting the output when a short circuit is happening. This is for the safety purpose of the batteries. You might be having a doubt that the battery has no charge. I will short circuit the battery directly and please watch. See, it has pretty good ampere. That is why the single strand of wire is melting. Now you have completed an 8.4 volt 2S battery pack with a capacity of 3 ampere. Now we will assemble a battery charger for one cell. For that we will connect the battery in this holder like that, and we will use this BMS, and this BMS is using micro USB for charging. This battery positive and battery negative are the terminals to the battery. The battery positive will connect it to the positive terminal of the battery, and battery negative will connect to the negative terminal of the battery. And this out minus and out plus are connected to the load. If you are having a LED or any load, you can connect this out plus and minus to that particular load, and this minus and plus are the input charging voltage. If you are having a 5 volt, you can give it here, or you can make use of this micro USB port. If you are having a mobile charger with a micro USB jack, you can just connect it to here and it will charge it. If you haven't subscribed to our channel yet, please click subscribe button. Press the bell icon so that you will get the notification whenever we upload a new video. If you have any suggestions, please comment on this video so that we will know that. We will use a double side tape to fix the BMS on the back side of the battery box. I am using a power bank for charging this battery. If you like our video, please click like button. If you do not like our video, click dislike button. I am connecting the micro USB jack. You can see the blue LED is lighting because the battery is fully charged, and if I am short circuiting the output terminal, now it will become red and then back to blue. There is no problem on it because the BMS system by default has short circuit protection enabled. Let me try to connect another battery. That is also fully charged. I will connect a motor as the load to the BMS. You can see the red LED is lighting because when the motor is connected, the voltage will drops. Then it will go to the charging mode. That is why the red LED is lighting. I have disconnected the charging port from the power bank. Let's drop some voltage there and then charge it. Now became fully charged. If you haven't subscribed to our channel yet, please click subscribe button. Press the bell icon so that you will get the notification whenever we upload a new video. This is Tech Insert signing off. See you in another video. Till then, goodbye and please take care.